This is my oscillation experiment. And the purpose of this lab is to analyze and observe motion of a mass attached to a spring and then compare it with a computational model of the same situation, then eventually answer if the system is follow the energy principle. The overall result should have the observation and computational models align in terms of x and y position versus time graphs, and the change in energy should remain constant throughout. Next is some fundamental principle covered in this lab. First of all is Newton's second law. It states that F net equal to the change of momentum over change in time. In this lab, net force is also equal to the force from the spring pointing up and the force from the gravity pointing down. And expanding the equation, we'll get this, and we will use this to find the L naught later. And next is energy principle. It states as the change in the energy of the system will equal to the work of the surrounding plus heat. And so the system of this lab is a mass and attached to the spring in the earth as well, leaving the surrounding with nothing. So delta E will equal to 0. Expanding delta E will have the change in kinetic energy with the equation down here, and the change in potential, spring potential energy, and gravitational potential energy. And some other equations are velocity update formula and position update formula. They are both from Newton's second law. Next is observation motion. First of all, we have the mass of the object of 0.4 kilogram, and the length of the spring when fully stretched is 0.7 meter, and the initial position and initial velocity, since it starts from rest of the initial velocity is all zeros. Using tracker to analyze the motion, firstly I found the oscillation period. So one period is one curve of the graph, and so the average of one oscillation period from total of 3 consecutive curves is 1.52 seconds. And next is using this relationship between the spring constant and the period, I found the spring constant to be 6.872 Newton over meter. And lastly, I found the relaxed length of the spring using this equation from the two previous slides. I got the L naught of 0.1261 meter. Just using closed grid to create a computational model for my experiment. Starting with some initial conditions such as the mass of the object and the position and velocity initially. And next is some constants such as the gravity and the spring constant and the L naught that we found from earlier. And to create a spring computationally, I'm using the next three line, and I also put in all of the energy equation from earlier. In the calculation loop, I calculate the gravitational force and the spring force, and then adding them together to get the net force. Meanwhile, I'm updating the velocity and position as well as the spring, and finally is calculate the change in energies. As a result, here are the two graphs comparing the observational model in red to the computational model in blue, and this one is the x position versus time, and this one is the y position versus time graph, and both of them show that the real-world observation is almost perfectly aligned with the computational model. There's still some deviation is because there's still some sources of errors. First of all is the computational model is perfectly isolated from its surroundings. However, in reality, there's still some work done by the surroundings on the system. Another source of error I found is using Draco to analyze the motion is as I might pointing at the wrong center of the mass. As a result, the red graph doesn't perfectly align with the computational model. However, is the energy principle satisfied? Yes, it is. Even though the energies are transferring into different forms, the change in energy remain the same throughout. As we can see that the orange line is remain constant throughout the graph, demonstrating that the system is isolated, meaning that the energy is conserved. In comparing the oscillation from x versus y position data, eventually I'll just get the spring constant different, but the overall result should not be affected. Thank you for listening.